Okay, so when we think of connective tissues, we have to think of it like a jello mold. Did you know that there's a jello museum in Leroy, New York? Moving on. When you make a jello mold like this one, with the fruits suspended in the jello, we can make a crude but useful analogy to connective tissues. All of our connective tissues have cells. And we're familiar with cells and their nuclei from looking at things like simple cuboidal cells with the nucleus right in the center. The cells in connective tissue they're various, and we can have things like mast cells, fibroblasts, osteocytes, all cells that we will slowly get to know. But this is like a jello mold here with different kinds of fruits in it. The fruits are like these specialized cells suspended in the gelatin. But what's in the gelatin? If you've ever made a jello packet, you know that it's just water and jello. The jello mix is really just soluble proteins, like horse hoof. Just kidding. Actually, I'm not. But these proteins, they suck up the water and they harden into a gelatin. This is the same thing as the goo in which your specialized cells are suspended in connective tissues. Aside from the specialized cells in a connective tissue, which that is one of the three main components in any connective tissue, aside from the cells, there are proteins like the proteins in gelatin. In a connective tissue, we have only three types of proteins: collagen, reticular, and elastic. Whereas epithelial tissue was classified by the shape of the cells, connective tissue is classified by the amount of each of these fibers it contains. We're going to call these proteins fibers. There's one more component of a connective tissue, and that's the goo, or the water, in which the jello proteins are dissolved. In our jello mold analogy, the water would be what is called the ground substance of a connective tissue. It's like the background goo. Sometimes, though, this doesn't have to be gooey or watery. Sometimes it can be a hardened substance like bone. When we consider tissues from here on out, we're going to use this term matrix. This term combines the protein fibers and the ground substance and lets us think of a connective tissue as specialized cells and then the background substance in which the cells are suspended. So you're going to see this term, matrix, and I want you to be aware that it refers to both the ground substance and the fibers together. That jello mold kind of looks gross. Before we even get started, let's make a realization. None of these pictures here have a lumen or an open space. Nope, the middle one doesn't. Sorry. So, no, there's no lumen. Correct. The epithelial tissues that we previously covered, they lined an open space. But these connective tissues, they're like packing material or filler. And so there's no open space. Connective tissues can be divided into two categories, making it a little bit easier for us to conquer them. The first category is loose connective tissue. I think that when students hear this title, they think that loose applies to how the cells are either packed in or spread apart, right? Loose or packed. Untrue. The term loose applies to how the fibers, like collagen, reticular, and elastic fibers, are distributed throughout the tissue. In loose connective tissue, the fibers are not pushed up against each other. They form a loose network that suspends cells in the surrounding goo. Look at these pictures on the left and the right. You can see the protein fibers as lines, and they're not pushed up against each other. They're spread apart, forming a network. The picture in the center You know what? Just try. It has protein fibers, kind of. You can't see them. I also want to point out right now that one connective tissue does not have to have all three fibers in it. So the three loose connective tissues are areolar, adipose, and reticular. And we're going to look at them in a little bit more detail.